Okay, so we got a transformation T of xy equals x plus y, x minus y, 2x. That's like a point in R2, a point in R3. And any point in R2 or R3 can be associated with an arrow from the origin to that point, right? Okay, so is T a linear transformation? Well, show that T applied to, and they should have an extra set of parentheses in here, do they? No, they don't. You know, there's something wrong with their notation. Okay, so I'm going to abuse notation because your book is abusing notation. I need to say T of one vector plus another vector, right? But T applies to just an ordered pair. Well, it doesn't even apply to an ordered pair. It applies to two numbers, x and y. And now we're applying it to ordered pairs. It's not consistent. There's a type error in this. So you're going to have some programming classes. Try not to make type errors. I mean, that really is important. That screws up your program. Okay? So I'm abusing notation. Because the type of thing I'm putting here is not the same as the type of the thing I've got here. But you'll get the point regardless. Nope, I don't need an extra parenthesis. Okay? Really, I would need an extra set of parentheses here. And I should have one. Your book doesn't. Okay? And I disagree with your book on this. I'm probably wrong somehow. I can't imagine how. But I really can't stand it. I've got to put a parenthesis around this. A set of parentheses around this. Okay? Can't put a parenthesis around anything because there's only one. Okay. And you know, these little comments and ravings are important about getting notation right. You really have to do that. And in programming, you really, really have to do it, or your program doesn't work, and you have no idea why, because everything looks okay. And then you got to spend days debugging the stupid thing. Well, this isn't a programming class. That's all I have to say about that. But, okay. It works in mathematics, too. If your notation's wrong, you're not thinking clearly. If you're not thinking clearly, you're less likely to do anything right, or to do everything right. Probably do something right. Okay. Well, let's get this. Now we have to show this. Why do we have to show this? Well, that's one of the properties of linear transformation. That's how it looks here, and I'm not going to go through a whole lot of detail. Since I've got the extra parenthesis in there now, I can do this right. See, my program is about to crash because I didn't fix it there. Okay. Well, T of x1, y1 plus x2, y2. Well, x1, y1 can be added to x2, y2. And clearly you get x1 plus x2, y1 plus y2. Okay? And what's that equal? Well, that equals what you get over here, right? T of xy equals x plus y, x minus y, 2x, right? Or the triple? Well, the first coordinate here is x1 plus x2. So x has been replaced by x1 plus x2, so you replace all your x's by x1 plus x2, right? So you're going to have an x1 plus x2 here, and similarly, Your y is now y1 plus y2, so you're going to have y replaced by y1 plus y2, right? And then when you do the same thing here, you're going to have x1 plus x2 minus y1 plus y2 quantity. And then you're going to have 2 times x1 plus x2. Okay? Now I know the direction these things go in because after you've done a couple dozen proofs of the properties of linearity, of linear transformations, you kind of know where they're going. Because they all kind of work out the same, but you got to practice. Otherwise, you don't develop a feel for where they're going. But what happens is very similar to what happens over here. We've got to separate this out to where we've got a t of v1 plus a t of v2, right? Okay? Or maybe we write what t of v1 plus t of v2 is and see if it's equal to this, right? Okay? So I'm going to choose that route because it's a little more obvious. I mean, what I can do here is I can separate things out, but I'm not going to do it. I'm going to do t of, didn't leave myself room. Okay, t of v1 plus t of v2 equals what? I don't want to write v1 and v2. I want to write t of x1, y1 plus t of x2, y2. Corresponds to what I just wrote, but it's not what I just wrote. Okay. Well, t of x1, y1 is x1 plus y1, x1 minus y1, 2x1, and then it's x2 plus y2, x2 minus y2, 2x2. Okay? That should be pretty clear. Well, if I add those, what do I get? I get x1 plus y1 plus x2 plus y2, right? And I get x1 minus y1 plus x2 minus y2, and I get 2x1 plus 2x2. Okay? This is equal to this, but we need one more step. Okay? These aren't in the same form, so it's not 100% clear that they're identical. Okay, we have to look at it and say, yeah, that's going to simplify to this. Is going to... No, we've got to write it out. Okay? So, since I have room here, I'm going to rearrange this one. Now, first of all, x1 plus y1 plus x2 plus y2. Is that the same as x1 plus x2 plus y1 plus y2? Well, yeah, it doesn't matter in what order you add a bunch of things that are being added, right? So I can rearrange this to just say, okay, that's x1 plus x2 plus y1 plus y2. And now this is identical in form and content to this. Okay? Now how about this? Is this the same as this? Well, if I wanted to change the form of this, I could distribute the negative through here and then change the order to get the order of this, but that's not what I'm doing. I'm changing the order of this to get this, right? So I'm really going to need two steps. I want to write this as x1 plus x2 minus y1 minus y2, so that I can then distribute the negative through here and or factor the negative out and get what I want. Okay? Now here, all I have to do is factor out the 2, and this is the same as this. Then I just have to change, well, I just have to write this now as x1 plus x2 plus y1 plus y2, x1 plus x2 minus the quantity y1 plus y2, 2 times the quantity x1 plus x2. And now this is identical to this, completely identical. And we can say that they're equal without having to wave our hands. Okay? We've locked it in. We've locked in this property of linearity. Now, you have the other property, C, T of CV equals C times T of V. And I'm going to leave that one alone, but it comes out more easily than this one does. And you should do that.